All right. Welcome everyone to the Pavement Preservation and Cold Recycling presentation hosted by the City and County Pavement Improvement Center, as well as the Caltrans Division of Local Assistance, the California Local Technical Assistance Program Center, hosted at Cal State Long Beach. And if you could please introduce yourself into the chat box here. Just click on the bottom of the screen right where it says chat on the bottom and introduce yourself and the city, county, or agency or Caltrans that you work for. We can load questions into the Q&A box down at the bottom. And we're going to go ahead and get started now with the presentation. I would like to introduce David Jones and John Harvey from the University of California Pavement Research Center at UC Davis. If you'd like to go ahead and start things off, John, that would be fantastic.
Great. Thank you, Daniel. And can you hear me all right?
Yes, I can.
Very good. Thank you. Thanks for the invitation to Dave and myself. As mentioned, we're with the University of California Pavement Research Center, which also hosts the City and County Pavement Improvement Center. So we're going to tell you a little bit about CCPIC is our acronym, a little bit about our brief introduction to our training program, and hope folks will take a look at our training program. And then I'm going to give sort of a quick background, which I call how good pavements go bad and what's the role of preservation and picking the right treatment at the right time. I'm going to give a very brief intro to that. And then Dave's going to pick it up and talk about a specific treatment that I'll mention in the intro, a set of things that we can do which are under the umbrella of cold recycling. Get the screen working here. Okay, so our website is shown up on the top there, www.ucprc.ucdavis.edu/ccpic. Our mission is to work with local government to increase pavement technical capability through timely, relevant, and practical support, training, outreach. We don't really do research. We translate research that we do for Caltrans and others do for Caltrans and federal government and put it into a form for local government that's easier to use, and then do the outreach to get it out there and help bring the knowledge and the practice to people. Our vision is local government managed pavement that lasts longer, costs less, and is more sustainable. And we are sponsored by the League of California Cities, the County Engineers Association of California, and the California State Association of Counties. I'm going to mention two certificate programs. The first one is the Pavement Engineering and Management Certificate Program, a wide range of audience for our different classes up there, and for the whole certificate from technicians and folks up to some upper level managers may be interested in some of the classes that we offer. 88 hours of training gets you the certificate. If you break that down, that is 5 hours a month over 18 months. We have a number of the classes up. We have enough classes up now that you can actually complete the certificate, and we're continuing to build out our curriculum. I keep forgetting to update this. All of the classes are offline. About 28% of them are online live, and 80% are recorded self-paced. So just throwing that up there, we do have another certificate program in pavement construction inspection. If you go to our website and go to the top of it, you can get all the information about our training program, which is managed by our CCPIC, one of the group partners in CCPIC, which is the ITS Berkeley, UC Berkeley Technology Transfer Program. Okay, so talking about asphalt pavement now, we're going to start with aging. And asphalt is a hydrocarbon, just like maple syrup, just like the plastic in the dashboard of your car, just like the rubber in the tires of your car. And one of the things about hydrocarbons is they're made out of chains, and if we put them under stress and hold that stress, then they can relax that stress. And that's a very important thing for pavement, asphalt pavement, particularly at the surface, because the surface is expanding and contracting continuously, day to night temperature changes, across the seasons temperature changes, and those changes are restrained and therefore they are stressing that asphalt pavement. Asphalt pavement is particularly weak in tension. So when the asphalt is contracting because it's getting cold and that contraction is restrained, then that puts that asphalt material in tension. If the asphalt is really stiff, the stress from that contraction is going to be higher. And if that stress is higher than the strength, then you get a crack, an age-related crack. So what has aging got to do with it? Well, if we look at the top right here, asphalt starts out as hydrocarbon chains that can move fairly unencumbered slowly, but it moves as a thick fluid. As time goes on, a little bit of the material that's in the asphalt goes into the air, called volatilization, but the main thing that is the process of aging is that as hot air gets into the asphalt, you start getting crosslinks, which we have represented it here with the little gold bars. As aging continues, those crosslinks become more and more, and what they do is they make it so that the hydrocarbons can't slide past each other. So what that does is it makes the asphalt stiffer, and it makes it so that the asphalt can't relax those tensile stresses that come when the asphalt gets cold. Once you have enough of those and we get a contraction, eventually that stress, tensile stress, will get higher than the strength, and we will get a crack that starts at the top and then propagates down to the bottom. So that's shown here. Those of you with engineering background, I always say I don't want to cause PTSD, but if you go back to your statics class, you remember you had one problem in there where you had a restrained beam and you had a thermal contraction in it, causes tensile stress, and you had to calculate what was the stress and was it higher than the strength. So that's the same thing we're talking about here. We will make these presentation available. Those of you who want to go through the equation, it's on the bottom there. But the key is aging causes increased stiffness and less relaxation. And as we have those day and night temperature changes, and it gets cold at night, gets cold in the winter, that's when we get those higher stresses. So how much stiffer does it get? The initial stiffness, we have a rapid increase in stiffness over the first 5 years, and then we tend to reach a steady state increase in stiffness. When you get out to about 15 years out, depending on the climate region, hotter climate region will get there faster. Central Valley, desert, inland empire. A cooler region will get there slower. North coast, up in the mountains, south coast. But you get 2 to 5 times stiffer. That gives you an idea. It's 200 to 500% stiffer. And we're losing that ability to relax as well. If we have good asphalt compaction, good compaction makes it so that the surface is less air permeable, and good asphalt compaction is going to help slow down that aging and potentially cap off the maximum aging that occurs, because if the hot air can't get into the mix, the hot air can't cause aging. Okay, so age-related cracking leads to top-down cracks. It cracks first in the transverse direction, then typically it will crack again in the transverse direction, almost halfway between the previous cracks. Here we can see those transverse cracks in my left-hand photo here. Got a little fatigue going on over here. And then eventually the shortest direction is longitudinal. So if we crack it a couple times transversely across the road, eventually the next time it cracks will be longitudinal, and what we've created is block cracking, and that's where block cracking comes from. Now, if I have existing age-related cracks under the new asphalt, or I have shrinkage cracks in a cement-treated base or something that's been cemented, particularly if the cement content is high, we'll get higher shrinkage. Those will reflect back up. So, for age-related cracking, what are the strategies? Well, the first strategy is to use mixes that are softer at low and intermediate temperature. So that sort of means, around 50 to 70 degrees. And then whatever low temperature means, whatever your coldest temperatures are. We need to particularly focus on softer materials in the top 2 inches. And then we worry about it to a lesser degree down to 4 inches. And if we've got pretty good compaction, we really don't have aging below 4 inches. So one of the ways to do that is if you're currently specifying a 64-16 or a 64-10 asphalt, if you go to a 64-22, that -22 means that that material is softer at lower temperatures. The -16 means -16 degrees Celsius, and you'll have the same properties that with your -16 at -22 if you specify a -22. Keep the surface protected from aging. This is what your preservation does, your fog seals, your slurry seals, but you need to do those ahead of the cracking. Those are not there really to seal the cracks for very long. Those are there to keep and slow down, keep from cracking, from aging, and slow down the aging process. So what frequency should we be doing those at? After aging has progressed to some degree in a cooler environment with softer materials, you don't have to do it as quickly, but in other places, hotter places, you have to go more quickly. But you want to do this before the cracking has gotten too extensive. So the other type of cracking, so age-related cracking happens just like the movie, all the time, everywhere, to all pavements. So your entire network is aging and subject to aging cracking. Now, fatigue cracking is another kind of cracking that we want to manage on. It only occurs where there are heavy trucks and buses, and it only occurs in the wheel paths. So this is the cracking you see in the wheel paths where you have those heavy trucks and buses, and what those are doing is they're bending the asphalt. And when they bend the asphalt, that causes tension on the bottom. And these cracks will typically start at the bottom and propagate up. As you damage the asphalt, as there's more and more of these loads, you're damaging it, creates a micro crack, and then eventually that micro crack starts to propagate up to the surface. Preservation does not stop or really do much about fatigue cracking. Preservation is about slowing age-related cracking. So fatigue cracking in the wheel paths, there's only 3 wheel paths here because it's a narrow road this one happens to be up in the East Bay Hills, but you can see it's in the wheel path. It's structural. It's going to happen if you have the heavy vehicles. If it happens, you need to replace the structural capacity. Preservation doesn't do much of anything about this. Okay, now I mentioned reflective cracking. If you have existing cracking in your asphalt or concrete or cement treated something under there, and you put the new asphalt over the top, that is a stress concentration. And the same process of fatigue and age-related cracking, thermal expansion and contraction is going to open and close that underlying crack, and heavy loads are going to bend over that crack. Except now it's going to go faster, both of those processes, because it's a stress concentration, and that will drive that crack up to the surface. So if you're doing a mill and fill on existing cracked stuff, the cracking will tend to come up faster than if you had a solid new asphalt layer of the same thickness, even if it's 1.5 inches, because of that stress concentration. So for load-related cracking, the strategies are it eventually becomes alligator cracking, and then the pieces come out, and that's what a pothole is. Pothole is the whole end of the process. Surface treatments, again, do a little bit to slow that, but really those are about age-related and block cracking. You can do periodic mill and fills or dig outs in isolated areas if you have localized deep cracking, but these become much less cost effective once alligator cracking is extensive. And you want to consider, this is where if you get extensive cracking, you want to consider going to the cold recycling that Dave's going to talk about, whether it's age-related top-down cracking, where you go partial depth, or you've got cracking all the way through the asphalt layers, and maybe even some contamination or no base underneath that, that's when you want to start thinking about the cold recycling. So to summarize, desired mix stiffnesses, age-related cracking, which leads to block cracking, all pavements everywhere, all the time. You want to be softer at intermediate and low temperatures in the top 4 inches, particularly the top 2 inches. Just gave a talk yesterday at the Public Works Officers Institute. What that means in the top 2 inches is you want to minimize the amount of wrap up in that layer, unless you go to higher levels of wrap, above 15 to 25%. And then there are technologies and approaches where you can keep that softness but still accommodate wrap. Polymer modification, using polymer modified on the surface or rubberized hot mix are both great for dealing with age-related cracking because they're nice and rut resistant at higher temperatures, but they stay nice and soft at the intermediate and low temperatures. That's what the modification does. For fatigue cracking, and again, this is only where we have the heavy vehicles, we want to keep that softness for the age-related cracking, but not so soft that we get rutting. We want kind of a Goldilocks licensed professional engineer over there on the right. She's looking for that Goldilocks solution of rut resistant, but still soft enough at low and intermediate temperatures. But then as we go below the surface, we want to start becoming stiffer, particularly if we're putting in asphalt that's greater than 3 or 4 inches. The stuff below 4 inches, we can put some more wrap in there or use stiffer binders, and that will actually help us with the fatigue. Now, in all these cases, if I've got just residential traffic, I don't really need to worry that much about the rutting. But if I've got heavy vehicles operating, particularly at slow speeds, turning things, then I want to particularly care about the rutting up at the top. I just want to mention that CCPIC has an asphalt specification that's available on our website that the Caltrans specification is really meant to prevent rutting across the state highway network. Is not really directly intended for residential streets. Our CCPIC HMA spec takes the Caltrans spec and then makes some tweaks on it for your residential mix designs.
Hi,
All
John. We
right.
have a couple of questions here if you
Oh,
got
okay.
a moment to
Sure.
answer them. So first question is, won't using softer oil create more potential for early age rutting?
Yes, if, well, that's the PG specification has 2 parts. The first part, let me go back here. The first part is the high temperature. Keep the same high temperature of your binder. That's the rutting part. That's at rutting resistance at 64 C. That's like 150 Fahrenheit. But what I'm talking about is you can ask for an asphalt that keeps the high temperature, but goes to a lower temperature on the second part of the spec. So go to that lower part of the temperature on the second spec, and you shouldn't be giving up any rutting resistance. Yeah, so that's it, the answer to that question.
Okay, we have a couple more questions here. Will an AC overlay that is 1/2 times the existing AC thickness control the reflective cracking?
Probably not. Unless it's unless you're talking about an 18-inch existing asphalt layer and you replace the top 6 inches. If you're doing 1.5 inches, 2.5 inches, maybe getting up to 3, it will help. But remember the age-related reflective cracking is temperature, and the thicker the blanket you put on that, the more you're damping those temperatures. If you've only got an 1.5 inch overlay, it's still getting hot and cold at that crack an inch, 1.5 inches, and it's doing the expansion and contraction.
Thank you. That is all the questions we have for now.
Great. I think I'm going to stop sharing and hand it off to Dave.
Thanks, John and Scott. Um, Good afternoon, ladies and gentlemen. I'm just going to pull up my screen here um, and share it with you. I'm also going to turn off my video so you don't have to look at me while I present and we don't destroy our bandwidth. But I'll try not to mute myself because then you won't hear me. All right, so moving on to the cold recycling, it's kind of going to build on what John has said. This presentation is an abstract of the CCPIC training cold recycling session, which is about 8 hours of all the knowledge you need to know about doing a good cold recycling project. We're in the process of recording that right now, so hopefully it'll be up and available for you. It's going to be one of those ones that's pre-recorded and you can do in your own time. So this is kind of a snapshot of some of the stuff that I thought you might find interesting. All right, so I've broken it down into 4 parts. Quick introduction so that we're all on the same page. We'll go into the types of cold recycling, and I'm going to probably tell you something new that you haven't heard before in terms of how we define cold recycling, and then just touch on why we think it's a good idea for you to consider cold recycling as a process instead of continuing to use your more traditional approaches where they might not be appropriate. Then we can wrap it up with a quick summary and take some more questions. So as you probably all know, because you either manage roads or you drive on them or you do both of those things, many of our pavements all over the world have essentially passed their use-by date. They were built long ago with a specified design life. We've seen a lot more traffic using our roads. We're seeing more trucks on the roads. So a lot of those roads that we have are structurally deficient for the traffic they carry, and we're seeing that in terms of the distresses that are on the roads. If you're from the counties and you have a rural county road network, you probably have figured out by now that a lot of those roads have actually evolved from old gravel roads. So they have a huge amount of variability in them, and they essentially don't have an engineered structure. So they too are having problems with the traffic that we're putting on them, and we don't have a blank check to go out and rebuild them. So we're doing the best we can with available technologies, which are typically mill and overlay or just an overlay or a surface treatment or whatever we can afford to do. Climate change is also factoring in. So we're taking those old roads that are structurally deficient, and now we're seeing more intense storms. We're seeing landslides. We're seeing localized flooding, all of those sorts of things. And this is shortening those roads and also shortening some of those treatments that we're putting on the roads. So we kind of have to come up with doing it better with less. We need rapid, effective repairs or rehabilitation, whatever we're looking at. We need to do it at the lowest possible cost. We need a little bit more resilience out of it, so we need to make it better than it was before to be able to handle that higher traffic and the climate issues that we're throwing at it, and all trying to keep the road user happy at the same time. And that's not an easy ask. And what we're finding is that taking those cracked roads that John showed you, putting thin overlays or surface treatments on the top of that, or milling some of the material off and putting a new overlay on that are just not cost effective. They're not lasting very long, and those distresses are coming up. And we need to make better use of our money. The same issue in terms of, if they're completely shot and the mill and overlay is not an option, pulling out all of that old material and replacing it with new material is cost prohibitive. And generally not feasible in terms of being able to handle traffic. If you're in an urban area, people need to use those roads. They don't necessarily have an alternative route to get out of their homes and go to work. So John covered the failures, so I'm not going to go into that. We obviously have catastrophic. We have the top-down distresses that John talked about, and then we have the bottom-up distresses. And this is where we think of cold in place recycling, because whether we have top-down distresses or bottom-up distresses, our traditional toolbox of solutions is either a surface treatment for some of those top-down distresses or a mill and overlay or an overlay on those bottom-up distresses. The problem is that if we don't get to the bottom of the distress, then that distress comes back up again. And John went into that, and I don't need to do that. But cold recycling, if we use it appropriately, allows us to remove all of the distresses. And if we want to, if we can, increase the structural capacity to prevent those distresses from recurring. So we have this situation here, and we put a thin overlay on the top there. Total waste of time, very expensive, and not sustainable in terms of using your maintenance funds. Deeper problems here. We've got some serious fatigue cracking in the wheel path. We can see a lot of pumping. Doing a wheel path dig out on this, we can see that didn't work. This photograph was taken about 3 years, 2.5 years, 3 years after the dig out was done. And you can see what we've done is we've been fiddling around on the top here where the major problem is down at the bottom. This core was taken out of this layer here. So we really want to make sure that that we get to the bottom of this distress so this sort of thing doesn't recur. So that's also just temporary, not sustainable. So if we do it as in a schematic in this picture here, and we put an overlay on the top there, or we mill some of it off and we put an overlay on it without getting to the bottom of it, that is, like we said, temporary, expensive, unsustainable, simply for the reason that those cracks are just going to come back up again because we're taking care of the top when the problem is down at the bottom. So really what we want to do is recycle all of that material. There's nothing wrong with the materials. They're just aged and they're a little deficient in terms of structure. We can add a recycling agent to this recycled layer, get rid of all the distresses, put a new surfacing on the top there. And that's really what we're looking at because we believe it's going to be much longer lasting. It's going to be more cost effective. And certainly sustainable in terms of how we use our maintenance and rehabilitation funding. So that said, let's just touch a little bit on the types of cold recycling. And I'm sure that all of you are aware of terms like cold in place recycling, full depth reclamation, deep in situ recycling, cold foam in place recycling. There's probably 100 acronyms for all of these things. And those are all legacies of history where equipment manufacturers adapted existing equipment in order to do recycling. So they would take a milling machine and add an emulsion bar to that and turn that into what we would call a partial depth recycler. Could handle the top 3 to 4 inches of material and be able to give us a recycled layer. They would take a stabilizer or a reclaimer, add some bars onto that, change the teeth configuration on that, and give us a machine that we could do full depth reclamation with on that. Since recycling has taken off, the industry, the equipment industry, have done a lot of developments on their machinery. We have a single machine that can go from anywhere from 2 inches to 12 inches of material that can throw it out the back and give us a good layer that we can run through a paver if we wanted to. We still have the modified wheel versions that can crush aggregate and move that material around a lot. And then we've also had the introduction of central plants where if we can't achieve what we want to do in place, we can take off our good materials, we can strengthen the underlying layer, we can make repairs to the underlying layer, we can run our stockpiled engineered materials back through the central plant and put them back on the road there. So my message to you is don't get hung up on FDR, CIR, PDR, all of those types of acronyms. Really, we just want to use cold in place recycling. We want to get to the bottom of the distress, and we want to increase the structural capacity where we can. You put out a specification, the contractors know what equipment to use and how to do it. So we're moving away from the specific terminology. We don't need to do that anymore. So a lot of flexibility here, a lot of versatility in what we can do. So if we're doing it in place, we can typically get down to a foot, maybe deeper in some instances. We can add recycling agents to that material to strengthen it up. And we can base our decisions on site investigations and life cycle cost assessment and environmental life cycle assessment, whatever you want. If we can't do what we need to do with an in-place recycle, as I said, we can take off those engineered materials, treat the underlying layers, put those materials, the engineered materials, back onto the pavement after running them through the cold central plant and come up with a really good, strong structure. So we have a lot of tools, a lot of ways of doing it, but we can achieve a lot of things with that. So if you haven't seen it, and I'm sure most of you have, this is a quick example of a machine. So we spread active filler out the front if we need to. We run emulsion or hot oil in a tanker. We run that through the machine. It mills it up, processes that material, either puts it out in a windrow or just drops it straight into a paver at the back. That puts it down in a nice mat. Let me just fast forward it here so that you can see the compaction. We have rollers at the back there, and we'll be able to put traffic on the top of this layer, temporary traffic on it for 10, 15 days, a month or so while we finish the project. And you can see the distresses popping up here. So literally we can turn an old broken up road into a brand new road at walking pace. Really, really good strategy. And we can alter the depth, alter the recycling agent, depending on what we want to achieve with that road. We can do it in urban areas. We can do it in rural areas, under traffic. So really quick. And the beauty of it is we're using all of our in-place materials, and we can get traffic on here really quickly after we finished at the end of the day. So within an hour or so, we can put temporary traffic on the road and then come back and pave it later. We do generally need a thin surfacing on the top of it just to keep it all in place.
Hey,
So,
David,
yes.
we have a couple of questions. If now's a good time to kind of break it up here, and I appreciate everybody dropping their questions into the Q&A box. And like another attendee said, if you cannot find the Q&A box, just hit the ellipsis inside the circle, the three dots, and the Q&A box option will pop up. The first question is, my local agency has experienced problems with dozers being operated on county maintained roads during wildfires. This has resulted in structural cracking and surface damage. Are you aware of any studies involving dozer impact to asphalt roads that would support damage claims?
Wow. I'm aware of that happening. I have not been involved in any kind of discussion associated with putting a claim in to deal with it. I don't know if John, do you have any input on that?
I've seen it. I have not been involved in claims. I generally try and stay out of court for all reasons, but no, I have not seen a specific claim on that.
Yeah, I know how to fix it, but I don't know how to pay for it.
Yeah.
You're muted, Dan.
Oh, thank you. Yes, I have the horrible habit of testing my mute button. Will a 7022 outperform a 6422 on a local street that normally fails due to age, or is local weather having more of an effect?
I think that one's for me. So the question was a 70 what versus a 6422?
A 70-22, will it outperform a 6422 that normally fails due to age? Or maybe it's weather.
A 6422 overall will probably be a little bit softer, which should help you with age-related cracking. The reason to use a 70 is particularly if you have the potential for retting. The 70 is particularly in the desert region or sometimes intersections in the valley or the Inland Empire. But yeah, dropping the bottom number particularly softens it at the lower temperature. If you drop the top number somewhat as well, it will also help soften it somewhat. But you don't want to, if you've got that traffic condition, you don't want to do that if it's a retting type potential situation.
Next question, can you effectively compact CIR deeper than a quarter of a foot, I believe?
Yes, you can. compact it down to 12 inches with no problem at all. The photograph actually that you see on the screen here right now, as part of the presentation, that's a 12-inch recycle, cold in place recycle. The machine is feeding material straight into the paver. You have to see there's a modified paver, a modified hopper on the paver there, just to accommodate all of that material. 12 inches over a 12-foot wide road is a lot of material. And then this is a heavy duty paver. It has a tamping screed and set up on the back there. And then typically a 16 or a 20-ton steel roller on the back of that. And we've done extensive testing with this, and yes, we are getting compaction to the bottom of that layer. So yes, absolutely possible to compact a 12-inch layer of cold recycled material.
Excellent answer. How do you deal with utility maintenance access holes, valve boxes that may be in the road?
Yeah, I will cover that a little later in the presentation, but that is something you have to understand what you've got there. If it's manhole covers and utility covers, those can, if you're doing an in-place recycle, those can be dropped. That's the sort of standard practice, is that they just lower those, cover them up with a steel plate, run the recycle through, and then open the road back up again, and then take the plate out and raise the manhole again. If you're doing a cold central plant, you can do that process, or we have seen workabouts, and I do actually have a photograph of that later in the presentation that shows the work around those utilities. So yeah, having grown up in a different country where they didn't allow utilities in the road, it was kind of easier. So obviously first choice is not to have utilities in the road, but if they're there, as long as the actual utility themselves, the pipe or the cable or whatever it is below the recycled depth, then it's not a problem. We can manage it.
Okay. We have a few more questions, but I think we're going to go ahead and let you continue on, David, and get to the questions here once you complete your presentation. So go
Okay.
ahead and continue. Thank you.
Thanks, Dan. I've pretty much covered this one. So that is one example of a new generation recycling train to do full depth. This is something that more of you might be a little bit more familiar with. Still really good machinery. It only has an 8-foot wide setup here, or a 2.4 meter drum. So full lane width, you either need to do 2 passes or you run them in tandem, but pretty much doing the same thing. This is processed with a grader afterwards, as opposed to going through the paver. And then the cold central plant, this is one example of them. There are 2 or 3 available out there, but this is one. It will handle 240 tons an hour of material. It's street legal, doesn't need an abnormal permit. And takes about an hour to set up. So really quick and an efficient process. This is kind of what it looks like. So your trucks bring the millings off of the project, dump them on a pile. They'll usually run them through a crusher, add the materials to a hopper. We have cement here for our active filler. We have asphalt, either hot oil or emulsion, that we can add to it. And then this process just churns it out and typically throws it back into the truck that just bought the wrap millings, and it goes back out to the project and is paver laid like you would do with hot mix asphalt, which opens up a new area as well. Is that around the country, and certainly in California, we know down in the Bay Area that we have huge issues with places to put all of the wrap that we mill off our roads. Why not use that in new cold central plant layers? So if you're doing reconstruction, new construction, lane addition, new residential areas, we can make use of this cold central plant as an alternative to traditional construction, and make really good use and get a new life out of that material. Then comes the question of which recycling agent do we use, or stabilizer do we use? If we're processing 100% wrap, then we stick with asphalt treatments. We either use emulsified asphalt or we use foamed asphalt. They're going to give you essentially the same result at the end of the day. So we can't say one is better than the other. There are instances when it's probably more better for the contractor to use an emulsion, and there are going to be some instances where foam is better. So we Certainly in terms of the Caltrans specifications, they leave it up to the contractor to decide what recycling agent they want to use, but they're both good. We also try and encourage adding some fines. 100% wrap tends to be a little coarse, so just a low percentage of some finer material to help with the active filler cement that we add down there, just to get a good tight gradation. If we're going into the unbound layers underneath, we have options. We can do nothing if it's a very low volume traffic and we've got good materials down there. We encourage the use of some kind of a treatment. So if you've got good engineered materials there, then we'll use asphalt treatments on that. If we've got more marginal materials, high fines content, some clays in there, then obviously we'd move more towards the cement. The most important thing that we're saying people is, don't base your decision on cost, base your decision on the material properties. All of these stabilizers and recycling agents are good, but you've got to use them under the right conditions. And you can't just say, well, cement's cheaper, so I'm going to use cement, because that could result in expensive maintenance down the road. Because if you've got good quality materials and you add cement to those good quality materials, the cement doesn't really have anything to do but get really strong, and in the process very stiff and brittle, and you run the risk of having some extensive shrinkage cracks in there. So we encourage to have an understanding of the materials. We suggest running some basic tests on it to come up with a unified soil classification system, and base your decision on that, and that will give you the best possible life out of your payments. Obviously, if you're doing a combination of the coal central plant recycling with underlying stabilization, then obviously cement or lime is usually your primary go-to solution for that. So here's just a basics. If you understand the unified soil classification system, it's based on some very simple laboratory test results. They give you a whole range depending on your gradation and your plasticity of the materials. And you can see with our good quality engineered materials, you'll see that the foamed asphalt and the emulsified asphalt is the preferred choice. 3 blocks means good. 1 means be careful. You want to make sure that you're still within the requirements. And then on our more marginal materials, especially on our full depth where we're going into the underlying layers, maybe bringing up some clays and a lot of fines, then cement is going to be good. And then obviously with very high clay materials, we'd be leaning towards lime first and then maybe cement after with that to get the strength. So it's an engineering decision, not just a, well, I feel like doing cement, so I'll do that. So moving on from that, with the background, is just a couple of reasons of why you should do it, and these are the sort of areas where I think it's an issue. And this is a project that was done down in Southern California in industrial area. It was a coal central plant study where they actually turned this really shot road into something that looked really good. 100% reuse of the in-place materials, and just a relatively thin surfacing on the top. So everything we're talking about is actually proven. It's out there in the field. We've got 25 years of experience out there in California, longer internationally. Caltrans has put a lot of money into doing research on this. So everything we're saying, we can back it up with data and experience. There are cold recycling strategies for almost any pavement problem. So show me the problem. I'm pretty sure I can come up with a cold recycling strategy to help you there. One of the most important things, I believe, is it removes the distresses. It doesn't cover them, and that gives us our longer life in the pavement. We have selected strategies that can increase the structural capacity. So if we're going deeper than the distresses, mixing up more materials with our recycling agents, we can get structural capacity. If we do a combination of stabilization with our coal central plant recycled materials, we can get a significant improvement in that capacity. Shorter construction times, less traffic disruption. That's really important, both from a safety perspective as well as a cost perspective. We definitely get extended pavement life by removing the distresses as opposed to covering them. A big thing for all of you folks that are cash strapped out there, we use all of those existing materials. We've already paid for them. Why take them out and put them on a dump site or use them as a low cost, shoulder backing or something like that. Let's make use of all of our materials and keep them in the road as opposed to taking them out. We require very limited new materials. We might want to add some supplemental aggregate. We certainly need a thin surfacing on the top of it, but not nearly as thick as some of our sort of heavy duty mill and overlays that we need to do for a rehabilitation project. It's definitely more sustainable if we design and build it correctly. So removing the distresses, not just covering them up. We minimize the trucking operations, which is a huge cost saving, and we also minimize disruption to the other road users. And of course, we're not running loaded trucks over our brand new road network. So we're reducing just some of those axles that the road will have to take. Definitely cost effective because we cut out that trucking, because we use the in-place materials, and because it's so quick. Those are all factors that contribute to that lower cost. We can recycle the roads again. Hopefully we don't have to do it for a while, but when our sort of 20-year design life comes up, no problem to go back in there and recycle it again. We don't have to take them out. It's a perpetual process. We have test methods and specifications in place. Caltrans has invested a lot of money in those. There are methods and specifications in the Green Book as well. And various local authorities have those as well. But we do have methods and specifications that are representative of our current knowledge and the current equipment we have. We've certainly streamlined all of those in recent years to make them effective. And then again, importantly, we do have experienced contractors across California that can do a good job and are well aware of how to do it. Put in another way, if we compare our traditional remove and replace strategies with our cold recycling strategies, some pretty clear differences here. Remove and replace is what it is. We remove and replace those layers. Cold recycling, we recycle to the bottom of the distress. That's a big difference there. Remove and replace, we're mostly bringing in new materials. Cold recycling, we're using pretty much everything in place, just bringing a new thin surfacing over the top of it. As we go deeper with remove and replace, as we try and get as close as possible to those distresses, the deeper we go, it gets more costly and it gets more complex in terms of construction. With cold recycling, no difference whether we go 4 inches or whether we go 12 inches on an in-place recycle. The only change that's going to come there is with the additional recycling agent and active filler that we need to put in to go to that extra depth. The complexity doesn't change, nor does the time that it takes. So as you see, project duration, the deeper we go, the longer it's going to take, the more road closures we've got to have, the more disruption to traffic we have. With in-place recycling, the duration stays exactly the same, regardless of the depth. And if we do a cold central plant, that is also quick because as we take those materials off, we process them and put them straight back again. The construction traffic, again, for remove and replace, the deeper we go, the more trucks we put on the road. For cold recycling, it's the same amount whether we go 2 inches or whether we go 12 inches. And at the end of the day, a remove and replace, if we don't get to the bottom of those distresses, is essentially just a holding action. Cold recycling essentially gives us a brand new road to start off with. It is hopefully structurally sufficient for the amount of traffic that we're going to carry. So minimize the amount of new materials we have to bring in, minimize the amount of trucks we put in. We can do it under traffic. And it's really quick. We can put the traffic back onto that surfacing within a couple of hours. We did have the question about utilities. They are an issue. We certainly have to take those into consideration. We obviously don't want to run a recycler through a gas pipeline. We need to know where those utilities are. It is common practice, standard practice, if we're doing an in-place recycle, just to drop those manholes down to below the recycle depth, put a steel plate over them, do the recycle and then come back, obviously mark them. We know where they are with the GPS, and then go back, open up the road and just bring up the manhole cover. So it's not a delimiting factor. We can work around those. Obviously, if we're doing cold central plant, we can actually pave around these and do a little bit of hand labor around the actual manhole itself. to accommodate those. So a little bit more problematic. It can increase the cost slightly. We're going to have the same issues if we're doing a mill and overlay as well. So certainly not an excluding factor. So I think we're getting close to time here. So just to summarize, we know that most pavements are old and all of them need attention, whether it's a preservation treatment or whether it's a maintenance or rehabilitation. Traditional toolbox is not really helping if we can't get to the bottom of those distresses that have been around, or if our pavements are structurally deficient. If we restore them back to their original structural capacity, that's not going to be good enough for the extra traffic that they're carrying today. We believe that cold recycling is probably the most cost-effective and sustainable alternative as long as we use it appropriately. We use the right strategy, we get to the bottom of the distress, we use the right type of recycling agent. Lots of advantages over traditional strategies. I'm not going to repeat those. Just ran through that whole list there. Do want to emphasize that we must use the right recycling strategy. So there is still engineering involved in this. We've got to do a bit of an investigation. We've got to understand how deep our distress is. We've got to understand whether they're top down or whether they're bottom up. And we've got to make sure that once we understand how deep we're going to go, what that recycled material is going to look like, and whether we use an asphalt treatment or a cement treatment on that. There is some engineering judgment required in that. But more than 25 years of successful projects at state level, city level, county level. Everybody's used them and are doing them and are happy with them. Supported by that comprehensive research and experience that Caltrans has invested in, we believe it is certainly something you should be considering, and we believe you'll be happy with the result. I'll leave it at that, and we can take a few more questions.
Hey, thank you so much, David and John and University of California Pavement Research Center for being here today, hosting this presentation, and of course, answering these great questions. And thank you so much to our attendees for staying on the line with us and joining us today for lunch. Also, the Cal State Long Beach, the California Local Technical Assistance Program Center here in California, and also the American Public Works Association. We have a few more questions to get to if y'all want to stay on the line. Otherwise, the recording will be made available on the CalTap YouTube channel. See here if I can post that link in here, or Scott, if you can please post that link into the chat here and I can dive right into the questions.
I got you covered, Daniel.
Hey, thank you so much, Scott. We make a great team. Let's go ahead and go through some of those questions here. What is the vertical clearance and width requirements of the CIR machine?
Good question. I can't give you them on hand. And there are various machines that are available. I gave you an example of one machine, but there are other manufacturers that have those. It's going to be about the same height as an 18-wheeler. It's not higher than that. So your sort of bridge clearances and that sort of thing, if a standard 18-wheeler truck can get in there, it can go through that. The recycler that I showed you there, the one that was doing the paver-laid, that comes out standard with a 12-foot drum on it. You can extend that drum. So if you wanted to do shoulders or something like that, you can put a drum extension on that. So you shouldn't have any issues with clearances. Obviously, if you've got low-hanging trees or something like that, again, if it can accommodate an 18-wheeler, you'll get away with, you'll be able to do the recycling as well.
Excellent and great information to know. Oh, here's a really good question as well. So many rural roads have very thin sections. What options for recycling are cost effective for thin road surfaces, say less than 4 inches of pavement thickness?
I'm assuming that that's total pavement thickness, so that's a combination of the surfacing and the underlying layer.
If one exists.
If one exists, if the underlying layer. Yeah, we see a lot of hot mix straight on top of native soils. So there are solutions. I think that the important part is you need to do some kind of an investigation to understand what you've got. And that's not a complicated process. Caltrans has a really good guide on how to do an investigation. You can download that from a Caltrans website or from the UCPRC website that
And
takes you through that process. Pretty simple.
we'll have a local government version of that out hopefully this summer also. A little bit simpler.
That as well. Okay, there you go. So you can do a pretty simple investigation, understand the materials you've got, run that unified soil classification system on it, and then be able to come up with a strategy around those materials. But even if you've got 4 inches of hot mix, severely distressed hot mix, over a fairly marginal material in there, it's got some plasticity, it's got a high fines content. You could do a 10 to 12-inch treatment with a recycler, and put a sort of 2-inch surfacing on the top of that, or even less. If it's lower traffic, you can get away with a chip seal. That'll work as well. You can run that process on that. So certainly those what I call evolved roads, evolved from gravel to paved. Certainly, cold recycling is a solution for that. And those concerns of thin structures, we can turn them into a thicker structure using those in-place materials that would be able to carry any traffic that you want to put on it.
I would kind of add that, what we're really trying to get to is make that asphalt surface that we're putting on the top, typically asphalt, could be a chip seal if it's particularly low volume road, but make it maintainable so that that asphalt's going to last quite a bit longer.
Yes.
Excellent, thank you. What is the maximum road grade or slope you can use for cold in place recycling?
I've been on some projects that would scare you. It can literally go up and down anything. Obviously, the direction of the train would change depending on the grade. It can get a little complicated if you've got really tight corners, sharp corners, sort of switchback corners, with a lot of super elevation issues. That becomes a little bit more problematic, and you might want to switch to a central plant recycling as opposed to an in-place recycling. But again, the trains are getting shorter. The equipment is, they've in the old days, the companies used to say, well, we have a milling machine that can recycle. Now the equipment manufacturers are telling you we have a recycling machine that can also be used as a mill if you wanted to. So they've certainly done a lot of development in their machines that can handle anything like that. But if there's an asphalt treatment on it right now, then the recycler can handle it. If it's concrete, yeah, that's going to be a problem because we don't have a recycler that can recycle concrete right now.
Next question, gentlemen. Is cold in place recycling more advantageous than the contractor trucking in hot mix asphalt from a local plant? If so, what is your reasoning?
It depends.
Contextual.
It depends on what your situation is. So if you run the numbers in terms of life and everything, if you've got a distressed pavement and your hot mix asphalt overlay is covering bottom-up distresses, then your in-place recycle is certainly going to be more cost-effective in the long term. On a cost-by-cost basis, again, if you're doing something that requires a full depth recycle compared to an overlay, your in-place recycle is probably going to be cheaper, or at least comparative with your remove and replace, depending on how much you put on. If you're putting a thin surfacing on, it's going to be cheaper than the recycle, but you're going to have to come back and redo that overlay in 2 to 3 years, whereas your cold recycle is going to last you 10, 15 years before you need to do anything with it.
So we really advocate, kind of building on what Dave said, we really advocate a life cycle cost approach. If folks don't know what that means, email us. We have some information on how to do life cycle cost. We have a downloadable spreadsheet on our webpage to do that. And Chico State Preservation Center teaches our life cycle cost analysis class, which is offered a couple times a year. So really it's life cycle is where the cost advantage particularly comes up. Now, of course, that's dependent on how long your asphalt treatment will last if you're doing a mill and fill versus how long the cold recycling. Both of those, the life is dependent on doing a good, having some idea of what your existing pavement is, and then also having good construction quality management for both of those. Any treatment can blow up if we don't have good construction quality on it.
Excellent. How does pavement fabric in the existing structural section impact the cold in place recycling process and end product?
Okay, so it depends on the fabric. If you've used a glass grid or just one of those things that are put in to slow down the rate of reflective cracking, and it's been applied properly, doesn't have wrinkles in it, it had a good saturation of the tack coat, etc., then those mill up really really easily. If you've got fabric that was put down badly, it's got kinks in it, wasn't saturated in the tack coat, that can be problematic. It can wrap around the drum when you pick it up, or it can tear it into shreds, which means you have to take it out. Um, there is a process that we can use where in our recycling train is that we actually include a screen and a crusher, what we call a multi-unit recycling train. So that'll come behind the milling machine, and that has a screen on it. And that screen will usually take out some of those fabrics that are in there. So again, as long as we understand what's down there from our investigation, we can usually deal with it. If you've got one of those polypropylene grids that don't break up easily with a recycler, then those could be problematic. But again, we've been working with the geosynthetic manufacturers to have most of their solutions be recyclable, because obviously we want to be able to show that as an option with it. So a lot of the geosynthetics that you're taking now, they actually do claim that they are recyclable with a recycling machine.
Is there a spec that can be shared to use for reference for hold in place recycling?
So Caltrans has just released a 2024 specification for partial depth recycling. They have an older version for their full depth recycling, which is currently being updated at the moment for asphalt treatments. The cement specification has recently been completed. So Caltrans has good specifications, and they're factoring all of the research that we're doing. They're factoring those into the specifications. So it's becoming easier, and they're more streamlined, and we're moving towards terminology and specifications that are all streamlined. So the partial depth recycling specification is very similar to the full depth one, which is very similar to the cold central plant. The cold central plant specification at this time, they only have a non-standard provision. I'm sure if you contacted your folks at Caltrans, they'd be able to give you a copy of that. But that should be formalized in the 2025 version of the specification. It'll come out as standard. The Green Book has specifications for full depth and for what the Green Book terms cold in place recycling, but that's actually a partial depth for dealing with top-down distresses. It doesn't align very closely with the Caltrans specification, but it is still out there. And then we have some cities as well, like City of San Jose, for instance, that does a huge amount of in-place recycling. They have some specifications as well. I think they're a little too stringent, but stringent is also good. But certainly the Caltrans specification, I think, is very representative of the knowledge that we have out there right now.
Excellent. There's another comment in here about the pavement structures having fabric between the layers, which is a good observation. Did either of you want to comment more upon that or reference
As,
back to your previous answer?
as far as
Uh,
milling
uh,
it, recycling it, or
It's just one of the problems. One of the attendees noted is that some of the pavement structures do have various fabric between the layers.
Yeah, that's inherent. I think again, as Dave was mentioning, if you do use fabric for whatever reason, the key is to get it really well glued in there with sufficient tack coat that it's sticks, and that makes it easier to grind up when or to mill. If you're doing a mill and fill, the same thing applies to mill and fill.
Yeah,
So
we do see fabrics out there that's got kinks in it, and it comes out looking like the day it was put in. You know, it's still gray, and you can see the individual fibers in it, all of those things. If you can see all of that, it probably wasn't doing any good at all to start with. In terms of retarding, fabrics don't prevent reflective cracking; they retard the rate of reflective cracking. So if something comes out and you can see what it looked like in its original form, then it wasn't put in properly and it wasn't doing anything for you. But if it comes out black and it's hard, it's almost brittle, the milling machine is going to be able to eat through that pretty quickly. So again, it boils down to the investigation. If you're going to pull a couple of cores out of the road, you'll be able to see what that fabric looks like. There's probably a good chance that it's even debonded from it, and you can make a decision from that. But as long as the contractors are aware of it, they can deal with it. It's contractors don't like surprises. If you tell them there's no fabrics in it, and they come in with a wad of horrible stuff that wasn't installed properly, then that is going to be problematic.
yeah, and you might get a claim.
Agreed.
You might get a claim. You will get a claim. Yeah. Yeah.
Can a FDR/partial depth be capped with a cape seal for a residential neighborhood?
Yep, it's really a traffic dependent thing. And if you're happy with that thin of a surfacing on it, we've certainly seen it being done. It's a very popular technique. Um, if you've got buses, it probably can handle the garbage trucks as long as they don't turn too viciously there. They can handle it. Buses are probably a little bit more of a problem. And if you're in Sacramento and they come around with that big claw during the rainy season and pick up all of that, all of your branches and Christmas trees and all the rest of it, you might start seeing a little bit of mechanical damage on that. But again, no reason why you couldn't do it if your design procedure shows you that it'll work structurally and survive. You probably have to do preservation treatments a little bit more frequently on a Cape Seal than you would have to do on hot mix asphalt, but it is certainly an option, and it's common practice around the world to do that. Yeah.
Have there been any so you mentioned San Jose, but are you aware of any projects, cold in place recycling, I assume, that have been completed in Southern California?
Yeah, hundreds. So the one example in the photographs that I showed you with that Coal Central plant, that where we did what we would call an inverted pavement structure. So we pulled I didn't do it. The contractor pulled off the good materials, put in stabilized the underlying layer, and then processed those materials and ran them back through. I believe that was done down near jeepers, and I'm slipping now, in the city of Industry. But there's a huge amount of cold recycling. County of LA, City of LA, um, uh, lots of other counties down there, San Bernardino, they all do it as standard practice. They have far more projects than Caltrans does in fact. Yeah.
I apologize. I'm gonna have to go to my next meeting. Um, so like to thank everybody. I don't know if Dave's still available, but I actually
I can
have to
hang
go to
around
my
for a
next
little bit,
meeting.
sure.
Okay, thank you.
Thank you so much, John. So we'll try and do the best we can here. We still have a few more questions to get through here, about, wow, 11. We'll see if we can get through them today. How can we tell if the subgrade has failed, and will this affect the process at all?
Um, It's often pretty easy to tell if it's a subgrade failure. If you've got fatigue cracking on your pavement, you're going to see the pumping of the fines, as we call it. So you got sort of white stuff or lighter colored stuff coming through the cracks. That's an indication that your subgrade has failed. And if you have deep deep, wide ruts in your pavement. So not something that looks like a railway line underneath the truck tires, but sort of wide ruts that are wider or as wide as your wheel path. Then those and sort of rounded as opposed to squared. Those are usually good signs that your subgrade has failed. And that again, that's fine for cold recycling. It just is just going to give us better information about the what kind of recycling strategy that we follow. But if the subgrade has failed, we can certainly deal with it.
Excellent. I don't know if you're going to be able to answer this question, but what do you believe is typical for Caltrans when it comes to utility raising after lowering and paving? Perhaps from the standard specifications or something of that nature.
Yeah, I believe they are covered in the specifications. Obviously, they're not covered under the actual recycling specifications themselves because Caltrans specifications, if it's a general issue that covers different sections in the pavement, then they're covered in a separate section for all of those sections. Caltrans, the majority of their road network does not have services and utilities underneath them. So that's beneficial. Obviously, if their roads go through built-up areas, then there are probably going to be some facilities in that. So on all of the projects that I've actually been involved with for Caltrans, I actually haven't come across any problems associated with utilities, but certainly in the urban areas, pretty much every project we work on, we're going to have to deal with those facilities. So, it's like it's not a new issue for contractors. They just deal with it. They know how to do it and they deal with it, and it's kind of standard practice. Obviously, if they don't have to do it, that's great for them. But it's not an issue for them to deal with those manhole covers and vaults and etc.
Excellent, thank you. Do we have a cost comparison between cold in place recycling and R&R in an urban environment with lots of utilities, kind of referencing back to the previous question?
Um, we certainly can do them. I don't have anything offhand, and it's going to be a case by case basis. You don't want to generalize. Um, but if you're doing remove and replace, you're probably still going to have to deal with those utilities, even if it's a lot of handwork around them. Lowering them is not as complicated as it sounds. I've certainly seen contractors do that really quickly, and then raising them back up again is not a major issue. And if some of them can be covered, then they can be covered. Um, but it's kind of difficult to pin a cost on it because it's going to vary on a project by project basis. If you're removing everything out, obviously you're milling around it. If you're putting those materials back as a cold central plant recycled material, that's going to be cheaper than taking all of the old stuff out and bringing new hot mix in. That's definitely going to be the cold recycling option is going to be cheaper. Um, if if you're doing like a partial depth recycle or something like that, you're not going to the full depth of the material, you'd probably have to run a cost assessment on that to see which is the most effective one. As long as you use an accurate indicator of how long your pavement is expected to last. If you still have distresses down at the bottom there, then you actually have to factor that in because the cold recycle is going to give you a longer life than a Mullen overlay that's covering existing distresses.
Excellent answer. Thank you so much, David. What's the minimum overlay thickness?
Well, like we said, you can do a chip seal if you wanted to, depending on the traffic. Caltrans typically does 15/100ths of a foot or 2/10ths of a foot. That's common practice for those for cold recycles. So that's anywhere from around about 1 3/4 inches to 2 1/4 inches that they would do that. Cities, it varies from city to city. Some cities like a little bit more asphalt down there, just so that they have something to work with when they come back and do a Mullen overlay. They don't obviously you don't want to if you're doing a Mullen overlay, you don't really want to be going back down to base. You want to have some asphalt underneath that, so they might thicken it up a bit. I can give you an example that we ran a whole mechanistic design process with an inverted structure. So take out the existing materials, stabilize the underlying materials, put the engineered materials back. We had 4 inches of hot mix on that design for a traffic index of 19. So that's like the busiest Caltrans route out there. And we can get a 40-year pavement design life with 4 inches of hot mix on the top there. So that kind of gives you an indication. You don't need a foot of asphalt on top of these materials to be able to handle the very heaviest traffic that Caltrans can throw at it.
It's great. It sounds like would result in some significant cost savings for a larger project or a
Very
larger
much so.
strip of road. Any issues with the running the cold in place recycling system on streets that have conventional asphalt with ARAM and RHMA overlays?
Um, yeah, you have to be careful with that. So your rubber is a gap graded mix. Um, that's where the G comes from after RHMA. So the major problem that we see with that is you have a coarser gradation. So you are going to need some supplemental aggregates in that. Um, if you're recycling 100% of rubberized mix, then we can run into some problems with constructability of those because although the asphalt has aged, the rubber hasn't. Rubber doesn't age at the same rate as the asphalt does, so the rubber still has a little bit of bounce in it. Um, so, so you have to take that into consideration. It's a little bit more difficult to construct, a little bit more difficult to compact. Right now, Caltrans's requirements say that you can't include more than 25% of your recycled layer can be recycled rubber, and that's just to overcome some of those issues. We've gone up to 40 and 50% on some pilot studies where we've added supplemental fines, not much, around about 15% of fine material, and we just spread it out on the top and then recycled that in, and that dilutes some of the rubber and helps us with the gradation of the material. So we take out some of that coarseness of the gradation, and those have worked well. We've had some pilot studies with Caltrans that have been down 3 years now, and they're still performing very well. So again, not impossible, but you need to be aware of it. And we need to design it around what you have in the road.
Okay, winding down here with the last 5 questions. Is there a typical percentage of deep failure on a road when it becomes most cost effective to fully recycle rather than perform several localized dig out repairs?
I think again, case by case basis, but pretty much they say anything more than 15%. So if more than 15% of your roadway is going to be a wheel path dig out or a deep patch or something like that, then it's going to be more cost effective to do a cold recycle on it. And I think as costs get more expensive, certainly labor costs, if you're doing patching, if you're doing wheel path dig outs, they're kind of labor intensive operations, those. You often have to have multiple closures to do it, to get it all done. Those are expensive. And they're often not very long lasting. If you're having to patch something, the patch often fails itself. Same with the wheel path dig outs that you saw in that one photograph that I had. So typically the number is 15% if you got less, but in some cases we're seeing it down as low as 10, that it's more cost effective to do a full recycle.
Excellent. Does rubber chip interlayer have any impact of or on CIR?
Um, as long as your recycled depth doesn't go through the middle of that chip seal. Uh, I've been on projects where the recycle depth has been right on that interlayer, and that can be a little bit problematic because you leave a little bit of it behind, you pick some of it up, and you tend to get some fairly large chunks of rubber into your recycled mix. So again, very important to do the investigation. If you have one of those layers in it, either stay above it, which is often not possible because those interlayers are fairly high in the pavement, So the idea is then to go through it, make sure I have a little bit of additional recycle depth to go right through that into the middle of the next underlying layer, and then it won't be a problem. Yeah, you can do it. And there's certainly Caltrans has plenty of projects where we've done that.
Excellent. So this one kind of tagged onto the question from a couple moments ago about, any concerns with CIR on rubberized AC in pavement fabrics. So any general concerns with that has not already been discussed?
I don't think so. Anything additional? Again, know what you've got. I think that's the most important thing, and then we can work around it. You don't want to find those. You don't want to get those surprises when you get out and you're actually on the construction project. But as long as we know about them, there's generally always a solution that we can come up, a cold recycling solution that we can come up with to address it.
Okay. Are the Caltrans specs for CIR and FDR modified for local agency use?
I think they're applicable for local agency use. They haven't been modified right now. The Green Book certainly hasn't been updated to the same extent that the Caltrans specifications have. But I believe that the Caltrans specifications are certainly applicable for local use. You could apply them directly to that.
Okay, excellent. And last
Sorry,
question.
just sorry if I can just add to that. So Caltrans doesn't use the term CIR. Their specifications cover partial depth recycling. So that's essentially if you're dealing with top-down distresses through your top 4 to 5 inches of pavement, and then they have a full depth recycling specification which is obviously for your full depth, right down to 12 inches and deeper if necessary. And then they have a cold central plant recycling specification as well. They're all very similar. We've tried our best to streamline them. So there's nothing contradictory across the different specifications. They're all line up. And really the only differences now is how you sample those materials when you're doing your mix design, and the type of recycling agent that you might use, and things like cold central plant, where you can do multiple lifts of cold recycling. Obviously, that specification accommodates those issues, but essentially everything else is exactly the same across all the specifications.
Excellent. And just another comment here is just cold recycling also works well to use as a base course for widening the road and placing an overlay over the whole road. Do you agree with that?
Yes, absolutely. We certainly have seen that on very narrow roads. So if you've got an unbound shoulder, just your native materials out, you can mull that out as a separate exercise. You probably don't want to include that in your pavement if it's very marginal materials, got high clay content, or doesn't have a good gradation. But you can actually mull it out and turn it into a bit of a box cut there. And then when you recycle your good quality materials, you recycle that. And because we have a little bit of expansion with the materials, because we're adding new materials into them, you can use that extra fluff to fill up the void. Or alternatively, you can bring in a little bit of additional material and just throw it down on the road in front of the recycler. The recycler will gobble it up with no problem, and then you just pave to the required width of the material. So again, common practice. If you have good quality shoulders in your pavement, then certainly there are recycling machines where you can just bolt on an extension to the drum and then actually recycle that shoulder in as well. So again, a lot of versatility in your cold recycling options that you have.
Excellent, and excellent observations from our attendees. I'd like to thank once again David Jones and John Harvey, and also Eric Updike, who contributed to these presentations as well for their at the University of California Pavement Research Center. And we're going to be going ahead and closing this meeting out. Again, big thanks to CalTap Center, Scott Jakovich, and Caltrans local assistants, and of course, the American Public Works Association. Thank you so much, everybody. Have a great afternoon. Thanks for sticking around with us.
Thanks, Dan, and thanks for the opportunity to share the knowledge. Thank you very much.